outside the desiccator. So what happens? Inside the desiccator there is hard loss of moisture, but outside the desiccator it becomes dry. So once it becomes dry, look at the strength. What has happened? Reduces. Almost it's not binding. That will not happen in clay. Clay, you made a sample, keep it outside, it will be dry, it will hard. But in this case what happened? This strength is very close to zero. So obviously what happened? When they constructed it with moisture, once it becomes dry, they just get separated out. They have no cohesion between them. These particles are spherical. So that's the reason it could not bind. One, this particle is spherical, angularity is not there, it cannot give friction. It is also spherical, and when it is dry, it has no cohesion. Whatever the cohesion, when it is, like you see, when it is wet, you can bind it. So that is known as your apparent cohesion. That will be lost, and that was lost. So these things, we had to justify them, why we need 15% sand. So this way, you have to say, and this is another reason, so that if this is the, and this is also answer to another problem I have, this one. Because in the previous case it was dry. This case it was dry and went off. But the other case, oh sorry. Here it became wet also problem. There are lots of rain and it went up. Okay, this I will try to explain it again. There, here the problem is became dry, no strength, side collapse. Here it became lots of rainfall, it could not bind, they are not binded, also it created problem. So for that reason, so these are the different properties of the fly ash. It's like for a concrete may not be that important, but as a geomaterial it's important. One is your self-hardening, other is your pozzolaning, they are different. Because sometimes, like there navily, that is another one, this MIMO in Bangkok. So if I have got a high calcium fly ash, it has got its some strength. You simply compact it and leave it, it will be cementitious. But that's not the for other case. So this is your pozzolanic. So I need to depend upon its cementitious strength or pozzolanic strength. I will come to that. Like we have discussed so much about sustainable material in terms of high strength concrete. I will tell something about low strength material. That is also there. Like when I am talking about geomaterial, or even suppose say the road embankments, the pavements and so there I don't always need high strength. So this is the property, some of the micro properties. I don't want to discuss more. For last 3-4 days you are going for that. Your same, EDX, XRD, all these things should be done as part of research. The client may not understand all these things, but that you leave it, because consultancy, they will come today, they will ask you their need tomorrow. When I ask them why you come today and ask tomorrow, they said because our need was yesterday, but they will come today only. So that way some of the things you have to leave them and forget it. But you have to do your further research, keep yourself ready. Suppose in future somebody else comes, so that time you have to explain him why it happened so. So this is another waste, ground-granulated blast furnace slag. Just for sake, because I some modulated, because I know for last 3-4 days you have gone through that. Here I just made a plot. Sometimes we need to know my local material. So I said GG base I am not going to use it for my concrete. So as I said, I am using as a cementitious material. Cementitious means it should be a binding material, not always for concrete. So then, which one we to use it? What is the parameter? Anything from the power plant, I mean the steel plant will do that GGBS? So that's why there are different properties. I try to plot, you see that around 50 slags from different sources. And then you see the variation, there is a factor called basicity factor. You have to see whether that slag is usable or not. Not that people are using slag, I will use it. So that way you have to, based on the chemical property, use all these are chemical properties. Ratio of the CaO by SiO2, L2 by SA2, and all these things. Basicity factor. So based on this, there are different boundaries, and see where it fits. Then only go whether I will put in cement or I will use it for other cementitious material, as a cementitious material. Here I am talking about the fly ash. There are two grades, ASTM, Class C, Class F, everybody writes. But you see, there is a wide range of Class C and Class F. I faced that difficulty particularly when I was doing for the Navy. It is neither Class F nor Class C. Because if you say Class F, means that is not cementitious, low calcium and other things. Recently I got another fly ash because our Indian coal contains large amount of this carbonous, and it become 40 to 50% of the fly ash content comes. So now many power plants are adding imported coal because the land is limited to them. So they are sometimes one plant in Paradip, Odisha, they are totally importing all the coal from Indonesia. Because the land is small, there should be very least amount of fly ash, and that immediately they should be use it. Because they don't have the place to dump as a ash pond. You don't have the liberty now to have a ash pond of 100 acres. That's not liberty now there. Total 100 acres you are getting to develop a plant. So in that case, it's not fitting. So then there is another classification you can do. They are somewhat more. One calcalic, ferrocalcalic, then you also sialic. All these you have to make to see not only to narrow classification of Class F and Class C. This Class F and Class C is very narrow classification. Very difficult to identify in terms of that. In fact, when I started the fly ash, that time the regulation was up to 12% you can go for carbon. That is a loss on ignition. I had faced the difficulty, I was not able to reproduce my data. But today I will get OMC and MDT different, next time I will go to OMC, MDT different. Because that time there was no need to go for this microstructure, but when I felt I could not reproduce my data, so I think something is therein. And that time India there was only 2 scanning electron microscope. One in Tata Institute of Fundamental Research, another was at IIT Kanpur. So I was fortunate to get that as a student. I had the access to that ACM, scanning electron microscope. Now many are there. So through that only I try to study which is the things which is hindering, or it is my fault or fault with the material. Later on I found it has been changed. Now thermal plants are producing less than 1% of LOI, then carbon. So that time, so that was an issue. So similarly, we need to know exactly the chemical content of it accordingly in the broad classification where it will fit. And that time also I tried to do this. Then this is another fly ash. As I said, there are only 2, one ACM, I have got access to one ACM, and there was X-ray diffraction. It was, you will go give a line for 1 week before, if you are fortunate to get that week, otherwise next week. So that time I try to correlate. So in that correlation, I made a plotting between line content versus hum position. You see this hum position. X-ray diffraction hum position also tells about the type of glassy phase, and that I learned from a journal, because as I suppose a geotechnical engineering you will search for some other journal, but I will search for a journal Cement and Concrete Research, and again I publish also in Cement and Concrete Research, because that type of work, because I found unless we understand these fundamental properties of the material, where to use it different now, next, because I found it's not cementitious, I have to use or dump it somewhere as a road embankment material. So that's why also we divide the waste in terms of high value utilization, medium value utilization, low value utilization. We try always for high value utilization. If I can get something high value out of this waste, I should first use it, then medium value utilization, and finally the low value utilization. When I say no, nothing is therein, You simply dump it, but low value utilization, not that zero value utilization. So then I dump it as an embankment, as a replacement of earth. So then, so this is, one is your, that time say that is property will depend upon that type of glassy phase and amount of glassy phase. So then it will be pozzolanic and it will be usable as a cementitious or concrete material. So that always not possible. So I try to use a correlation. This is mostly that high calcium fly ash or slag. Slag has got around 35% of lime, where fly ash in our ordinary class A fly ash it is within 4-5%. So that I try to make it, is there a relationship? I found if depending upon the lime content, the home position varying. Home position varying means, so the type of like aluminum silicate glass to like calcium silicate glass, that type of things may come. So that glass will create, help me in that. And you see this, all what I am saying, that time of 90s, because that time I had no option to so much access to so many equipments to do it. So through correlation I was trying to see that my material is possible or not. So this is, I say, there are 3 types of the, based on a particular quantity, that based on this a chemical formula, the glass content based on the data from the literature and mine that I put it, it can be 3 groups. And then I said, I gave that cement and concrete paper, I said, I know glass, quality of the glass, quantity of the glass, fineness of this, that gives the strength of your mortar or concrete. So that time, there is only one paper of 60s or 70s. So that from there I took the mortar strength and I propose a formula, and that this is a predicted and observed value, that is what they have got it. Franklin and something of ASC old journal I searched in the library, I could get a data set and then I try to put it. Because when I am doing something, I have to see if sometimes all the data may not be available to you. So then I propose, that is how we do that R square value so much. That means this way, from a waste, if I am trying to make a mortar or a concrete or a cementitious material, these are the factors which are affecting. Next, another slag. This we are saying ferrochrome slag. I am not going very detail into it. I am talking about basic principle of some of the materials which can be used as a certain material or has been used. I am telling like fly ash, I have seen for last 28 years, how it is changing the places. And in one fact, another place we have used as a high calcium, high volume fly ash. High volume fly ash concrete. HVFA. So that up to, you have used up to 50%. And in that once as a in charge construction, I wanted to use sustainable, there is a green rating, that is GRIHA rating is there, or LEED. So your building should be energy efficient. So if you want to make a building, so it should be like different types of rating, platinum, gold and other things, or as per GRIHA it should be 1, 2, 3, 4 and so on. So there one thing is there, you have to use fly ash brick. So if you use fly ash brick only, you will get a very good point, and minimum 85 points if you get it out of 100, and if it is innovative then also you get more points. So sometimes this stricture forces you to think differently. So when I proposed to around 7-8 years before that I was in NIT Raulkela, so there I proposed to director that we will go for this fly ash bricks. Many senior professors opposed it because it's not proved, and then they said because I am not that, there some coal contains some radioactive material and all these things. So I said coal has radioactivity, again to burning, then fly ash, I am adding not fully fly ash, then how it is possible? So obviously very less content of it might be there, if something is there, I don't check it. Then he said, okay, get some bricks. So just to avoid that, some bricks came and it broke like anything, 40, 50 that strength, that your requirement is 70, so it was coming like 40, 50 and it was not satisfying the criteria. Then again it was discarded. But I didn't lose my heart there. I try to use fly ash cement bricks. So because they are the code, Indian code has that Folgy bricks, fly ash lime gypsum. So fly ash lime gypsum brick was very common and many people are using it. Many plants have been developed based on the Folgy brick. That is a fly ash lime gypsum. So I try to use cement only instead of lime and gypsum. 7 to 8%. And at one point of time in our own campus, we had got 4 plants, 32,000 per day bricks. And all our 302 projects, we used only fly ash bricks. So only thing that you have to give a rate. You, as a construction also, that rate should be there where the contractor should be do it. So we evaluated 3.5 rupees or 3.2 rupees per brick that was there, but we could use it. So that way, we earned once upon a time, and that way the contractor, in that he became so much excited, now using paper blocks out of the fly ash. All these paper blocks is doing out of fly ash. So that means you need to only, for that 1-2 months we struggled to find out the alternatives. How much cement we should do? What should be the its rate? And that you have to put in the tender, so the contractor has to do it. There is no bind option. So these are the things you have to go for. So this is another one called ferrochrome slag, ferroalloys corporation. So it is there in this. I am telling about different aspects. Here I will tell another aspect of research while using this waste material. So this is same EDX and all these things. I try to compare it with Indian standard sand, because this ferroalloys, ferrochrome slag, which they call it as the waste from ferroalloys plants, is granular. Basically you can grind it to your size, coarse or fine aggregate, anywhere you use it. So here I am taking the fine aggregates. So obviously you have to compare with Indian standard sand. So this I think not Ennore sand, but there is one quartzite sand, that prepared sand. That is Indian standard what we are telling. So this is same scanning electron microscope photographs. See the type of particles. There I was saying spherical particles of fly ash, and now you see the particles of another waste. So why this? I mean, why I am saying this as required for our, I mean, microstructure analysis. And you see, this is also there. I am seeing another picture. This picture nowadays not very popular. This is optical microscope photograph. When, as I said, there are only 2 scanning electron microscopes, we are working on optical microscopes. Now, but this is a recent study, one of my students did it, optical microscope. So from this we could not get it, but here. So you see the color, some is light, some is dark, and so on. So as a civil engineer, I don't have that much of knowledge, so I asked somebody, why they are different color? The metallurgy people said, so these may be the light metals, and these are the heavy metals. So I need light metal, alumina, silica, so that will be pozzolanic. And obviously ferroalloys contains, if you will see here, lots of iron, that is, they say spinal structures, heavy metals, that means. So this helped, this said, yes, I have got something at least. If you have heavy metals, it will have no pozzolanic and all these things, forget it. But at least some light materials there, and it is on the surface. So I can use it. Then this is the grain size distribution, this is the chemical formula, these are not there. So I will come to this such a study. Here I am saying particle shape analysis of ferrochrome. I took the photograph from here, as I said you, this optical microscope photograph. Scanning electron very high resolution required, here it is not much, you can get this photograph. Now everybody is familiar with AutoCAD. Then through this AutoCAD, try to find out the longest dimension, intermediate dimension, and for such cases the largest radius, all small radius. And then we did some analysis to find out the values, they call it as roundness index, okay, and I will come to shape factor. So those things, why it is required? This is what? Elongation index ratio, flakiness ratio, sphericity, shape factor, and roundness index. Optical microscopes, as I said, in most of the even university also it is available. AutoCAD everybody, all you know. So to you can do that analysis to find out how many particles are very angular, angular, subangular and rounded. Because my focus changed, it was spherical there, that is requirement. Here my focus is different. I want to correlate with a standard sand. So for that reason, we need to find out these properties. And these are the values, these are for standard sand, because standard sand we have got 3 grades, SS1, SS2, SS3. So based on, because it fits to its properties, there we compared. So after that, we can also find out the other way, bladed particles, prolate particles, equant particles, and all these particles also you can differentiate. This, there is a diagram called Jinks diagram. So this also recently, I mean that what you have to do, how to tell the people through publication only. So that's also there. So you can find out, so this is, you can use and find out its property to tell why it required. I am just telling you a small example here. Flowability. You see, these things, this is not tell to explain, just I am telling. Optical microscope photo, then AutoCAD analysis. These equations are there in the literature, you have to use it, find out accordingly, put it here to find out what is the type or shape of the particles. What it will say? This is another flowability. Flowability, because you say you have read about different formulas for workability and other things. So here I am talking about flowability, and that depends upon these particle shapes. I am trying to use a material. So this material, more important was that if I am using for as a sand, what its flowability.